So that's a benefit to that too. With our semi-structural formula, well, if we do some comparisons, this is a molecular formula. And all we're doing is stating is what's present and how much. But it really gives us no clue to the structure, does it? Because we can sort of work it out because this is quite simple. But if this was more complex, it wouldn't really tell us anything about the structure. What we've been doing so far is this. And this is the structural formula. Where we draw every bond. And when we say every bond, we sometimes have a little bit of flexibility for our ethyl, especially ethyl side chain, that might be just a little bit squashed up if we draw it out completely. But there's somewhere in between. The semi-structural formula is somewhere in between. And the way I go about drawing a semi-structural formula is I start at one end of my molecule. So if this was my molecule, I'm going to start with my carbon there, and then after that carbon, I'm going to write everything that's attached to it. And so this is CH3 on that carbon. That carbon has 3 hydrogens. And then the next carbon in the chain is listed, and what is bonded to it. And so we can build up a picture. It's not that hard to go from a semi-structural formula to a full structural formula because you're just drawing out the bonds. Now, that's pretty straightforward for ethane. But if we've got side chains and things like that, then we need a couple more rules. And so if we look at something like 2-methyl pentane, as we've got in our example here, well, we know how to draw this as a structural formula, don't we? We're going to start by looking at the pent, and we'll draw out our 5 carbons. And we're going to number them. It's probably easiest to number it left to right. That means our methyl will be on the second carbon in the chain. So now we've got this carbon here in our methyl group that's present, but it's not part of the chain. And so the way we get around that is we say, well, for this second carbon here, it has this hydrogen bonded to it, but it also has a methyl group, and so we put the methyl group in brackets to say that it's still bonded to that one, so bonded to the second carbon in the chain. So if just say we had this same molecule, but instead of all those hydrogens, we might have some other things instead. So we could have a Br, and we could have a Cl, say here. Then this part's the same. But now I've got to write in the bromo and the chloro to say that it's attached to this one is on the 4th and this one's on the 5th carbon in the chain. Does that make sense? So we're basically reading the molecule from left to right, and we're writing down the carbon first, and then after that carbon, everything that's attached to it. If it has a methyl or an ethyl side chain, then we have to put that in brackets so that we don't get confused and think that that's part of the main chain. And any other additions just get written on as listed after the carbon, the relevant carbon. Now, as I was saying before, this can be handy if you've got a big molecule that you're just trying to maybe look at some reactions. If you're asked for a structural formula, you must do it this way. Okay? And if you're writing out reactions, then this is not suitable because you won't be able to demonstrate your understanding of where the bonding is occurring if all you're using is the molecular formula. So you won't get full marks for that in a reaction. But if you can work this out okay, then this is fine for a chemical reaction.
So that is semi-structural?
This
formula.
is semi-structural. These two here are semi-structural. Okay, where we're just looking at the carbon and everything that's bonded to the carbon comes after it, listed in a line like this. This is for our molecule.
So what would you do if, for example, like there was a double bond or triple bond in there anyway? Would you have to state that anyway?
No, well see what happens is, just say, we've got a double bond in now. Now if I count my bonds for my carbon, this one still has 4, doesn't it? And this one has 4? Yep. So now, we've got CH, then we've got CBr, and then we've got CH2Cl. So we just don't write what's not there. Yeah, and if there was a triple bond, then we'd end up with 2 C's next to each other with no hydrogens or anything else in between. Okay, so any other questions about semi-structural?